Good afternoon, everyone. My name is Mayor Malfara, joined by my colleague Matt Dybert and our presenter Rob Fox with Hubbell. Before we get started, please note that because we are recording today's session, your cameras and mics have both been turned off. You are welcomed and encouraged to ask questions using the chat feature. They will be answered toward the end of the presentation. I'd like to thank our sponsor for today's session, Billows Electric Supply Company. We greatly appreciate their consistent support of the EAP, which allows us to offer these great presentations at no cost to you. It is now my pleasure to welcome Rob Fox from Hubbell. Rob is currently a Hubbell product manager who handles national C&I enclosure business with responsibility for revenue, P&L, product development, and product management. Welcome, Rob.
Thanks very much, Mayor, and thank you, Matt, for putting this together. Also, thanks to Billows for supporting this. Thanks also to everybody being here. Hopefully, we can walk through this presentation and provide information that you're looking for. And of course, I welcome questions from any of you about anything we're about to cover. So go ahead, Matt. So this may seem like a very simplistic picture, and I like to start this way because I want to be sure everybody in the room knows what we're here to talk about. This is a Quazite box, and in the field, obviously, this one happens to be in Alaska. And if you're anything like me and the people I work with every day, we see these things in our dreams and everywhere we go. So when you're on the street, take a look down as you walk along the sidewalk. Chances are outstanding you're going to walk across one of these boxes. Hopefully it'll be one of ours. So this presentation will go into some more depth on this. Go ahead, Matt. These things are underground enclosures, of course, are a whole wide variety of shapes and sizes and that sort of thing. I like to tell people we are in the business of making elaborate shoe boxes. Some of these things are literally the size of a shoebox, and of course, some of them are much, much bigger than that. And in addition to just pure size, they also come in a lot of different shapes, as this slide sort of illustrates, and a little bit of a variety in terms of different materials that these things are made from. There's some why behind that we'll also talk about. In addition, I like to just be sure that everybody understands the different brand names. Now, Quazite is what we present ourselves as in many cases. Certainly within the world of C&I, we are known almost exclusively as Quazite. But really, to be technical, I suppose that is a single brand name within the Hubbell Enclosures family. That family includes all of these brand names you see on the screen here. Within C&I, generally speaking, we're talking about the top three, the top line there, Quazite Pencil and Quazite FRP. The only additional one that may be of interest to you is the lower left corner ArmorCast. ArmorCast is a relatively new acquisition by Hubbell, maybe 2+ years ago. And we'll talk a bit about that. ArmorCast also makes polymer concrete underground enclosures, so similar product line. This is a picture, very recently took this picture in Dallas, Texas. Probably an obvious reason why I like this picture. The baby in the background just kind of sets this off. But in the foreground, in the shadow, you can see one of our boxes. This happens to be a PC 1212 that I've pictured here on the left-hand side, just to give you an idea of what this thing actually looks like. This is a relatively small box. It's actually a very small box, but it's also probably our most common, quote unquote, bread and butter box. These things are typically found at the base of a street light. Actually, this picture is a poor illustration, perhaps, of where you would typically find it. That's actually a center median strip where this thing is located, and that's probably atypical. Much more likely would be that this thing is sitting at the base of a street light to serve that street light. Very frequently, the logo information on the top of the cover will say street lighting or some similar thing. But this box goes out the door from our manufacturing facilities by the truckloads, by the tens of thousands really per year. and they are used frequently for those applications. Go ahead, Matt. I wanted to show this slide may be a bit may seem a bit out of place, but we're going to talk here in a few slides deeper about load applications and where these boxes should be. And certainly as a major factor of where they should be, there's also where they should not be. I use this red arrow here because that box in the center of the street is very hard to see, but that is a Quazite box, and it's parked in the middle of this intersection in the middle of Dallas, which is 100% incorrect. That box should never be in that location, with the exclusive reason being it's obviously going to be hit by traffic frequently. These boxes are not designed for that application. I think this picture perhaps is one of the better ones I've ever seen that illustrate a poor location for a box, but it's important that all of you that may be in the role of speccing an underground enclosure understand that difference, that deliberate traffic versus non-deliberate traffic is a common theme here, and certainly this is a deliberate traffic application. Go ahead. Also, wanted to show just a couple of pictures here of the breadth of underground enclosures. So, and for the most part, we're talking about the types of underground enclosures we've seen on these previous slides. But in addition to that, we also have some relatively unusual or maybe unthought of applications. This is a trench section. This particular trench section is about 12 feet long, and you can see over this gentleman's shoulder in the foreground that has an open end. The other end is open as well. These things are designed to link together for whatever length of run the customer may need. These are often sold into the railroad market. Go ahead, Matt, on the next one. This next picture is kind of a finished look of that same material. These things oftentimes run alongside of railroad tracks and are used to serve electric utility, could be used for fiber optics, really just about any type of utility that might be needed to run alongside the railroad track. And as I said, these things can be linked together for a very long length of run, could be as many as 3 to 5 miles of this trench. The trench itself is also load rated, just as our underground enclosures would be. So this is just kind of a did you know sort of slide, 2 slides. Go ahead with the next one. The next one fits the same category, I believe. This is an above ground enclosure by our CNI team. This would typically be used, it is used as a sectionalizing cabinet, but it would be typically found in renewable wind farms or solar farm applications, which also falls under the umbrella of CNI. So we are in the midst now of selling a lot of these into that wind and solar market. The next slide is also the same thing, Matt. This next slide is actually a solar farm. This one happens to be in South Georgia, but you can see here there's like three sectionalizing cabinets in this picture. But a farm like this might have 100 to 150 or more of these cabinets found throughout the acreage of this solar farm. So just be aware that when we say enclosures, you may picture a quote unquote typical underground enclosure, but that enclosures category also encompasses those trenches that I showed you, and then also these cabinets. Go ahead. So a slide here on how we go to market, and I think that may be of interest to you just from the standpoint of kind of big picture thinking. The dotted line, I understand this is a bit of a complex slide, but I'll try to simplify it. The dotted line through the middle, I want you to pay attention at first to the top half. This would be the inquiry. So the customer's calling us and asking about how do we get our order placed? Well, that on the left-hand side of that area where it says SKU, that's where the call is made to our customer service people. And along that path, I'm showing you demonstrations of questions that we are going to have for the customer or the customer is offering to us. And I highlighted 2 of those in orange because they are specific to the CNI world. The first one I've highlighted is UL listing. And that is critically important to a set of customers for C&I that we deal with. Probably 80% of our sales within C&I, maybe not 80, 60 to 80% of our C&I sales are going into the Department of Transportation customer base. Those customers insist upon that UL listing in most states. So it is critical that we offer a box and cover that meets that UL listing. And again, that is specific to the C&I market. So the same exact order that's coming through our communications market or our electric utility market, they may not care a bit about UL listing, but C&I certainly does. Those customers do. The next one I have highlighted is Buy America. And that is also a major factor within C&I, probably more so than the other markets that we serve. I'm not sure how many of you on this call are dealing with Buy America or are familiar with it, but within C&I and within enclosures, we have to deal with that quite a bit. And of course, Buy America has changed frequently as of late. Now, the typical Buy America provision that we are going after is known as BABA or BABA. Build America, Buy America. And with that, we have to ensure that the products that we're selling, these boxes, covers, or assemblies, or whatever the case may be, that they meet this Buy America provision. And that sometimes can be a challenge depending on where we're building the product. On a future slide coming up here, we're going to talk about where we're building these products. Now, below that dotted line, assuming that the order is actually placed, this graphic is really just demonstrating one thing, and that is that the C&I world deals with distribution. So when we sell as the manufacturer, we're not going directly to the owner. We're selling to a distributor, and the distributor most often to a contractor, and then ultimately to the end user. So just kind of a pictorial way of showing that we definitely go through distribution. So this is a detail on where we are found. Our headquarters is Lenoir City, Tennessee, on the right center of this map. We're just outside of Knoxville, Tennessee. That's the enclosures headquarters. But the other stars indicated on this map are the manufacturing locations. The next, we're a large manufacturer of the Quazite product here in Lenoir City. But outside of that, the next probably biggest furnisher of Quazite would be the Juarez, Mexico facility on the West Texas area you see here. So between Lenoir City and Juarez, as things stand at this moment, most Quazite boxes are going to come out of one of those two locations. And generally speaking, we divide the country east-west. So east side comes out of Lenoir City, Tennessee. West side comes out of Juarez. That's a general rule. It's not always the case. There are certainly exceptions to it, but that's generally true. To the far east, you'll see Rocky Mount, North Carolina. That was an acquisition that dates back a little over 10 years ago. That's the Pencil brand name, and we'll talk a bit about that product line. That's an HDPE plastic product. Since those years of acquiring Pencil, we have also added Quazite production on a smaller scale into that Rocky Mount facility. So they do a little bit of both, a lot of Pencil and a little bit of Quazite. And then on the far west, you'll see Chatsworth there, California. That's really LA area. That was the aforementioned ArmorCast acquisition about 2 years ago. So they're building, as of this moment, only ArmorCast. That certainly has the possibility of changing in the future, but that's the way it is at this moment. And then in the center of the country, our newest facility is Oklahoma City. We really have just gotten started with that. It's been about a year now. We're getting our feet under us. We're building more than we show on this map, Quazite, but they're actually building Pencil there. They're building ArmorCast there, and as well as Quazite. So that is a very, very large facility. And I've got some pictures here on the next couple of slides to show you that. Go ahead, Matt. So this is the first one, Lenoir City, and I want to draw your attention to the square footage just so you can get an idea of scale. This one's 75,000 feet. It's the oldest one, the first one building Quazite. When Quazite was purchased, when Hubbell bought Quazite, gosh, that was back in the early 90s. That this is, of course, what they were buying. This facility as well as the brand in Lenoir City, Tennessee. Previous to Quazite, the company was called Strongwell. Previous to Hubbell, I'm sorry. Quazite was owned by Strongwell, and then dating back even further than that, Strongwell bought it, interestingly enough, perhaps from Shell Oil Company. So the earliest stages of Quazite started with Shell Oil. Go ahead, Matt. So here's our Mexico facility in Juarez. I'm not sure. Is the bottom of the screen cut off for everybody, Matt, or is that just what I'm seeing? I can't see the square footage, but it is quite a bit. Go ahead, Matt.
120K.
Okay. Yeah, 120K on that one. So it's a little bit bigger than Lenoir City. And there are two plants in Lenoir City that are building the product. So just wanted to give you a sense of scale there. Go ahead to the next one. This is the Rocky Mount, North Carolina facility. As I mentioned, that originated with us because of Pencell. We have since added Quazite and added some fiberglass. That's what Quazite FRP refers to. And that was 185,000 square feet. So still pretty good sized facilities. Go on to the next one. Here's Oklahoma City. This is the as I mentioned, the newest one. And this one is 400,000 square feet. So substantially bigger than Juarez or Lenoir City or Rocky Mount. It's really a state-of-the-art facility. It's going to offer us a great deal of capacity. As of this moment, we believe we have more capacity to make in underground enclosures than anybody, especially once this Oklahoma City really finds its legs and starts producing product at its ability, its full capacity. Right now, it's a bit of a learning curve. It's a difficult product to make. Polymer concrete is a challenge, and making it well requires real skill. So once we get a workforce within Oklahoma City that is up to speed and can produce the product as well as we can in these other facilities, we, as I mentioned, we fully expect it to have the best capacity in the country for the moment. Go ahead. Here's Chatsworth, and this one's also 400,000 square feet. It's a very, very large facility, and they do a nice job. As I mentioned, this is a relatively new acquisition, but ArmorCast has a nice product line, and we think it's going to blend well with the Quazite product line. Couple of interior shots in case some of you perhaps on this call have not seen the inside of one of our facilities. ArmorCast and Quazite polymer concrete, similar operations. There's some differences in the way that those products are made. And probably to most of you on this call, that may be of little importance, but they are slightly different. The facilities themselves, it takes a lot of space to make these things. So you get a feel for that with these pictures. There are multiple workstations on that right-hand picture. You can sort of see that down the right-hand side of that aisle. Each workstation would be responsible for cranking out parts, be it boxes or covers, and those would ultimately wind up at the end of the assembly line with a finished assembly that would be loaded onto trucks and hauled out. The way this is done, it can vary from plant to plant, and it's probably more so than you may initially think. The material itself is channeled into these workstations in different ways. The product is dispensed into molds in different ways, and the way that product is settled out within the mold, it varies. So from manufacturer to manufacturer, the way that the product is built is going to vary from quite a bit. So just be aware of those circumstances, those differences. Go ahead, Matt. Generally speaking, kind of back to the product discussion, and I mentioned this early on, we break into two categories, below ground and above ground. So within the C&I world, at least 80% of our sales fall into the below ground category, although we do have some above ground, and that's primarily for C&I. That would be that sectionalizing cabinet I showed you early on. Other markets offer some other above ground products. I have some pictures here I'll show you, but they're generally pedestals of some sort that could be HDPE pedestals or fiberglass, as this picture shows you. But for the most part, that's not a typical CNI product. Go ahead. So this is kind of an overview of the different materials that we make. So when we are talking about Quazite and Armorcast, we're talking about a polymer concrete material, as you see on the left-hand side here. So that would be a polymer concrete box as well as a polymer concrete cover. The middle picture would show you what this Quazite FRP would be, and Armorcast also makes some version of that. That's generally the same thing with the cover, is exactly the same thing, polymer concrete, but the sidewall of the box itself is made out of fiberglass. So really it's a combination fiberglass box, polymer concrete cover. The next one to the right is the Pencel HDPE. So that box is high density polyethylene. Think of it as plastic box. In this picture, the cover is also HDPE plastic. However, Pencel offers options where you could put a polymer concrete cover on an HDPE plastic box. Generally speaking, that's going to be done because of customer preference, but mostly because of customer tier requirement. And we'll talk about that here in a few slides. The product on the far right is called Voltec. That came with us from the Armorcast acquisition. I don't think that's generally going to be of interest to most of you on this call, so I'll be brief, but that's more often going to be used in the electric utility market. That picture you're seeing here is much bigger than you may imagine. That's probably at least 8 feet wide, but perhaps 12 or more feet long. These are custom made, so those dimensions could vary on every box we make. This is designed to be piecemealed into a manhole in a downtown street circumstance. So if you imagine a big city manhole entrance, and if you go down into that manhole, the concrete walls of the utility tunnels down there, of course, fail after a number of years. So this product is designed to be pieced down into that area, built up, and then concrete poured around it so that you can, in essence, rehab underground tunnels that have failed or in the process of failing. Again, that's typically going to be an electric utility application. Go ahead. So again, here, this is kind of a repeat of the 2 slides ago. You've got polymer concrete material on the left. On the right is FRP. That's another version of that FRP product line. So the first one I showed you was a smooth wall fiberglass. This is a corrugated wall fiberglass. You're going to see corrugated wall on bigger boxes. So the first picture I showed you was probably maybe a 17 by 30, relatively small box. The one pictured here is just kind of a demonstration, but that would typically be used in much, much larger. That could go up as big as, say, 5 or 6 feet wide by 8 feet long. They can go in varying depths all the way up to at least 4 feet. Some cases they'll go 6 or even 8 feet deep. Those boxes have a lot of versatility in terms of getting to the larger sizes. That's where you're typically going to see a corrugated wall box. And then again, at the bottom that would be HDPE plastic. That is used heavily in the communications market. Again, CNI is probably not the major player for that product, although it's certainly available. And we do sell some pieces of that for customers that ask for it. For the most part, however, I take you back to the first one, the polymer concrete box shown here. That's your real bread and butter product material for the CNI customer. Go ahead. And then inside these boxes, there are all sorts of whistles and bells that can be added, and you see pictures of that stuff here, in addition to other things I'm sure that are not pictured here. But the racking on the upper left-hand picture, you can see on the right-hand wall of that. The inside also on this one shows a pulling eye that can be used to help pull fiberglass or copper into this box. The left-hand side of that box shows you a couple of terminators. Those are different styles of plastic inserts that can be used for typical conduits that would come into that box. That one also shows a mouse hole on the far wall. Those mouse holes can actually be ordered by the customer, and we'll manufacture it with the mouse hole already in place. The lower pictures are showing you some different things. The lower left picture is a lightweight cover that we refer to as SMC. That stands for sheet molded compound. That is a somewhat difficult process, but it results in a resin-based cover that is lighter weight than polymer concrete. So where lightweight is of interest or in need, perhaps spec'd, then the SMC cover gets you that lighter cover and maintains that high load rating capacity. So that's a relatively new product for us. It's been out on the market for a number of years, but in terms of the way it is applied to an underground enclosure, that's still relatively new. Where we see this perhaps being of interest would be in applications where OSHA or a city spec might call for covers that do not exceed X. Well, oftentimes when we have those sorts of provisions, a polymer concrete cover is heavy. So we can't quite get there on a polymer concrete cover, but perhaps we can get there on an SMC cover. Go ahead, Matt. So this is stone cold simple, and I apologize for that, but I hope to try to make the point that when we're talking about an assembly, an enclosure assembly, we're talking about two parts. We're talking about the box and the cover. We most often sell these things in two separate parts. So what you're seeing here would be two different SKUs, the cover and the box. However, we do offer some part numbers that accommodate both. So we sell those as an assembly, one part number for both. But be aware that, of course, if a customer offers us a part number that's for a box and does not match that with a cover, that it's conceivable that they think they're ordering assembly, but they're only getting a box. So something to be aware of in terms of the way our partner numbering system works. Go ahead. And generally speaking, again, I'm going to focus on C&I here for obvious reasons, but in most cases, as I've said a couple of times already, the Quazite boxes are the bread and butter for C&I. And it turns out the smaller size Quazite boxes are the typical sizes for C&I. So usually we will start small. The one on the right is a 12 by 12. And we'll go up bigger than that, of course, but not a great deal. We'll go up to as high as about 24 by 36 before the C&I customer base really starts to fall off or fall away from the bigger boxes. They are concentrated on those smaller ones. The one on the left is a 13 by 24, and that's also an extremely high runner, a typical box for the C&I world. And what I want to try to demonstrate in this slide is the difference between the two major categories. You've got the PG on the left and a PC on the right. Most of the boxes that go out of C&I are one of those two things. The key difference being the thickness of the cover. And why would we make a thicker cover? The answer is because of load rating. So we started back in the early days of Quazite boxes. We started with the PC box, undoubtedly stood for polymer concrete box. And that's the one and only thing we made. That box could make it to a tier 15, and I'll talk to you about that here in a minute, what that means. And eventually we got to a point where we wanted to go higher than that. The next higher rating is a tier 22. In order to get to that, we had to have a thicker cover. We basically maxed out the thickness of that PC cover. So we went to a PG cover since then. And since then, that PG series is more popular now than the PC series used to be. So by and large, we sell PG boxes. We still sell some of the old style PC in many cases. And usually this 1212 is probably the best example of where we're still selling the PC box. Go ahead. Also, just kind of a sideline, perhaps, the cover bolts that hold the cover down to the box, that can be an area of interest for customers, oddly enough, perhaps. The bolt shown on the left, that's an auger bolt. We call it an easy bolt, EZ. That is what we would consider to be standard. So if somebody ordered a box and cover and did not make a specification regarding that cover bolt, then that's the bolt they're going to get, the cover and the bolt and nut. The one on the right is a machine thread. That one is sometimes ordered. So we have customers that spec say a 13 by 24 box, and they don't want the auger thread for whatever reason. So they actually ask for and receive the machine thread, and of course the machine nut that goes with it. So we'll certainly see that. Now, that is almost all, or maybe every time, caused by the spec. So the best example I can give you is Texas DOT requires that machine bolt and machine thread, that machine nut. The nut happens to be brass in this case, and that's also spec'd by TxDOT. So we build that because they want it that way, not because we think it works better. In our opinion, the bolt and nut on the left works better, and the reason we use an auger thread is because of the condition that these boxes are going to be in. They're in the dirt, they're in the sand. The bolt holes themselves are going to fill with dirt and sand, and when you put that bolt back into that nut, at least with the machine thread, if it's full of that crud, it's either now or very soon going to mess up the threads of that bolt and nut. So we've gone to the auger thread, believing that works better. It certainly cuts through that sand and grit and goes into the nut much easier. The looseness of the threads allow for that grit to fall out a bit easier. Across the bottom, of course, the one on the left is just standard hex head. That just demonstrates what's normal. The one in the middle is a pin head, and a lot of our customers order that. That's considered to be a mild degree of security to try to just keep a vagrant from breaking into your box, under the basic principle that most people don't have a pin head socket, which is generally true. So the problem is, it is, of course, pretty mild. You can certainly get your hands on a pin head socket if you're determined to do so. But for the most part, I would say probably no less than 50 or 60% of our customers order the C&I boxes with a pin head bolt. The one on the right is I'm referring to that as a Bryce fastener. Bryce is really a brand name. There are no doubt many others that make the same thing. You oftentimes see that sort of a pin within say an Allen head type opening. And there are other types of configurations as well. The point being, it's a secure, it's an attempt at a secure method to prevent somebody from getting into a box. You oftentimes see that sort of a fastener in a public restroom. They oftentimes put up the partition walls with that sort of thing. The point being here, a customer can certainly use that sort of a bolt to put the box together, or put the cover on the box to try to prevent break-ins. Go ahead, Matt. Okay, so we're starting to drift more into the load rating discussion. Here, I want to point out very simply that a Quazite box is always at the highest load rating, and that's tier 22. The cover can be whatever you spec it to be. So this picture illustrates a cover being at tier 15. So if you put a tier 15 cover on a tier 22 box, question here, what's the assembly tier rating? Well, the assembly rating here would be tier 15. It's always going to follow the weakest link. In this case, the weakest link would be the cover. So if it's tier 15, then the assembly is tier 15. If it's tier 5, the assembly is tier 5. The advantage, however, is that the box is always tier 22. So in this example, if the customer ordered a tier 15 and then later decided, no, I really should have gotten a tier 22, well, you can just swap out the cover and now it's tier 22. So that's true of a Quazite box. That's not always true of other brands, not even other brands within Hubbell. So a Pencel box, for example, would not follow that rule of thumb, not necessarily. So if you had a cover the tier 15 and a box tier 15 in a Pencel circumstance, changing the cover would not change the assembly tier rating. Go ahead. Few other tidbits here. I mentioned the mouse holes already. The load requirements I've kind of touched down already. That load requirement, whatever it is going to be etched into the top of the cover. That may be of some significance only because we oftentimes are fielding questions from older customers. Maybe they've been around a number of years, and they send us a picture or a request to replace a cover, and the tier rating should, in almost every case, is going to be etched on top of that cover, so you can see what used to be there, and we can always go back and replace it. On the right is our what we refer to as logos. It's really just an etching on top of the cover. That is very common in most cases. When we sell covers, they do have some sort of logo. Usually for C&I, it'll say something like electric, or it may say street lighting or traffic signal, like this one shows here. Those are very common. We also do some logos that are made to order. We'll do a company name, or we'll do a utility name that may be etched into the top of a box. Whatever that is, we can certainly make a custom logo. We're really only limited by the space allowed within that area of the cover. On the lower left, sorry. On the lower left, I like to try to just use terminology, because that way we're all on the same page. So you can see what we refer to as a through hole is exactly that. The one in the middle is a knockout. I always use as an analogy of that, if you've ever used the galvanized steel wall boxes that have the small steel plug that you can basically push out with a screwdriver. This is the same principle. You knock out that center portion of those holes with a hammer, and it'll end up looking like the one on the left. But it gives the customer some flexibility. They can punch out whichever ones they want very simply. The one on the right is a terminator, a plastic terminator that's designed to accommodate pretty standard size conduits that would come into that thing. And you can see, if you're looking closely, that's that solid bit of plastic in the middle. Again, that would just be knocked out with a hammer. The Buy America I've talked about. And beyond that, there are plenty of other things. I think the previous picture demonstrated there are plenty of things you can do with these boxes in terms of providing options. Go ahead, Matt. And then this is just kind of a mix up of the different types of above grade pedestals. I mentioned those earlier, and I mentioned also that the pedestals, I'm sorry, the sectionalizing cabinet pictured here in the upper left, that's the kind of the standard C&I above grade product. The other products are not nearly as much used in the C&I world. Those are far more commonly used in communications for coax cable or fiber optic, for example. And then they're also heavily used in the electric utility market for usually their secondary pedestals or something of that nature that you might find in subdivisions or those sorts of things. But C&I, certainly we can sell them. It's just that our customer base doesn't typically request them. I think there's another slide of these. Go ahead. Yeah, so these are box pads and transformer pads. Now, C&I does sell some of these. As I mentioned, they're equipment pads really, but most often they're going to have a transformer parked on top of them. You can use a box pad, that would be the two in the upper left, or a flat pad, that would be the two on the lower left. And then also you can do some different types of configurations. So for example, on the lower right, on the left-hand side of the lower right, you can see that's a corrugated FRP box that could be as much as, say, 4 feet deep. And that might even be bigger than it looks here. It might be 4 feet by 8 feet. So a good sized box. And then you might put a pad on top of that, as shown here, with an opening, throat opening. So now a fairly large transformer can sit on that. And then the space, the box that's underneath there, is going to provide the installer with more flexibility to train the cable up into the transformer. And it also provides a little bit of better access in the case of having to do some maintenance. You can certainly get down into that box if you need to. And we do sell a lot of those. Sometimes that happens, or is spec'd on some of these wind farms or solar farms, where they want to use that sort of a configuration at the base of a tower. Go ahead. All right, so we've touched a few times on load ratings, and that's probably what most people think of when you start talking about how is an underground enclosure spec'd. Generally speaking, we're going to talk first about what's the cover, what's the box capable of carrying. There are 4 ANSI SCTE load ratings, and those are shown here: Tier 5, Tier 8, Tier 15, and Tier 22. those numbers generally correspond with thousands of pounds of load. So tier 5 is 5,000 pounds of load. It's a little bit off of that. If you look at tier 22, you think 22,000 pounds. It's actually 22,500, but it's close to that's generally speaking the rule of thumb. Each one of those would be, that's the design load is what I just said there. So tier 5 is this design load's 5,000 pounds. That has a 1.5 safety factor. So that tier 5 would actually be test loaded to 7,500 pounds. And you can see that across this table, how that would calculate. Go ahead. Many of our boxes, as I mentioned early on, are UL listed. Not all, but many. And that's generally driven by, again, the Department of Transportations that buy our product. They spec only a UL listed box. And what does that do? What does that really mean for us? Generally speaking, what that means is that UL is a third party tester. They're going to come into our facility, and they do so, I think it's quarterly, into every facility we have. And they, in essence, look over our shoulder and be sure that our processes do match what we are claiming. So when we claim our box is tier 22, UL is coming in and certifying that it meets tier 22. So without that third-party testing, you could stamp pretty much anything you wanted to on your cover, take state claims of whatever load rating you wanted, but there's no third-party overseer of that. So there's no way of knowing if that's actually factual. So when we sign up with UL listing, that's what we're signing up for them to come in and audit us and back us up. When we say it's tier 15 or tier 22 or whatever, they're going to back us up and say, yes, indeed, it is. Go ahead. This is kind of an important slide. Again, going back to one of the first things I talked about was deliberate traffic versus non-deliberate traffic. Quazite boxes, not generally speaking, always speaking, are non-deliberate traffic applications. So non-deliberate traffic, I think that requires a little bit of explanation. That does not mean it never is going to be hit by a car. It means that it's designed to be in an area where it's not going to be hit by a car regularly. It's not going to be hit all day long like it would be in the middle of a public roadway. So if you have a Quazite enclosure in an area adjacent, let's say, to a parking lot where it is not designed to be parked on every day, but once in a while a car may roll across it, that's what we mean by non-deliberate traffic. Deliberate traffic, of course, is the opposite, and it would be a box that's placed in the middle of a roadway. And that has a different specification. So starting first with what we do, which is the non-deliberate traffic, that is, again, the typical specification is a tier rating. That is conducted by this group, ANSI SCTE 77, who has written that specification. And we're going to talk here in the next couple of slides about what that entails. It's more than just that load rating, but suffice it to say, it is an ANSI SCTE tier rating system. By contrast, back up one more. By contrast, the deliberate traffic application would be the AASHTO. You can see that acronym here on this slide, AASHTO. Their spec for this is called H20. We do make a couple of H20 boxes. ArmorCast makes a handful more H20 boxes. So we can meet some minor requests for an H20 box, but it is, generally speaking, it is not our bread and butter. We don't really get into that very much. Roadway boxes are most frequently cast iron or something of that nature. So we can do it, but it's not really our wheelhouse. Go ahead, Matt. So this slide, I wanted you to see that when we talk about ANSI SCTE tier rating systems, yes, structural testing is the feature that everybody talks about, but it also encompasses all of these other things. So very frequently, for example, we'll get an email from somebody that says, hey, I know your product is tier 22, but does it meet the coefficient of friction? Well, as you can see in the bottom of this list, of course it does. In order for us to meet ANSI SCTE tier whatever, we do have, of course, have to meet the structural load rating, but we also have to meet all of these other aspects as well. So it is a kind of an all-encompassing specification that we have to meet all of these things in order to reach that tier rating stamp. The ANSI SCTE test or structural loading is actually a 3-part, and it encompasses these 3 pictures that you see here. So we load up the sidewall for the reasons shown in the picture. We load that laterally, we load that vertically, the first 2 pictures. And then of course the worst case, or probably the case that's the most difficult to meet, would be the cover test. That's the right-hand picture, where you're just simply loading it up in the dead center of the cover. So the bigger the box gets, the harder that test is to meet. And then when we load these things, it's not just a one-time load and unload and that's it. We load these things 10 times and then test them for flex, not just whether or not it can withstand the load. So go ahead to the next slide. I think there's a picture of that. So this particular instance, it's showing a sidewall test. So this is specified to be the plate that you'll see on the top. In this case, would be a 10-inch by 20-inch plate that would be designed for a Tier 22 test. They're going to load that to the specified load, and then on the right-hand picture, you'll see a gauge set up to test the flex of that sidewall. So ANSI SCTE says it must carry X load, and when it does so, the sidewall is not permitted to flex more than a 1/2 inch. So different materials will respond differently to that load. So polymer concrete does pretty well with that. The sidewall flex is kept to a minimum, it's certainly below 1/2 inch. Other materials such as HDPE, for example, it may carry the load, but the flex may be more than a 1/2 inch. So sometimes you'll have boxes that yeah, they can carry the load, but they don't meet the letter of the specification. Go ahead. So this would be the same test in a top load. You can see this is actually a misprint. It says here, shown here is a vertical load test of a Tier 22 cover. Well, actually, that's not a misprint, because you can see the plate itself is still 10-inch by 20-inch. So anything lower than a Tier 22 load test would actually be a smaller plate. They call for a 10-inch by 10-inch plate for anything less than Tier 22. Here again, you can see the load being applied to the very center of the cover, and in the background on the right-hand side, you can see the gauge that's testing how much flex is being applied or is going to result from this load. Go ahead. So just a couple of slides here. It's really much more of a make you aware. We certainly have a lot of installation information that we can provide for you and for your customers. We have a very prescribed set of installation instructions as to how this thing should be done. In most cases, it's pretty standard, pretty straightforward. There's nothing terribly enlightening about some of this stuff. You dig a hole, you put the box in the ground and backfill. That's certainly true. But there are areas where we can get into trouble because customers may not do some things, or they may go too far. And probably the best case of that would be where guy digs a hole, puts a box in the ground, and then he backfills it with heavy equipment like a bobcat or a backhoe. And those sorts of things can create sidewall pressure to the point of breaking the box. Of course, that would be the obvious result, but less obvious result, and one that we see from time to time, we'll get a call from a customer that says, hey, we installed these boxes in the ground a couple of weeks ago, and now none of the covers will come out. They're wedged in. We can't get them out. And long story short, you find that that's because they backfilled these things with some heavy piece of equipment. And when you look at the box now, you'll see that the sidewall itself has a bow in it. And that bow is so severe that it's pinching the cover and you can't get the cover off. So we get results like that generally because of a poor installation technique. Go ahead. Same is true of lifting this product into position. This illustration here is, of course, a very large box, and again, within C&I, we're not typically going to see the very large boxes, but we do get into some issues. So, for example, that lifting device in this case is a prescribed length. Reason being, if you use a very short section of line there to lift this thing, you're putting so much sidewall pressure on the box, you could actually break the sidewall. So we're looking for a longer attachment point and try to keep that load from pinching inward on the sidewalls and actually causing damage. It's also an illustration that ideally these boxes are picked up by the lift points as shown here. In the field, very frequently we'll get contractors that'll pick these boxes up by the covers themselves. So they'll bolt the cover into the box, and they'll pick up the whole assembly by using the pull slots in the cover, which is not at all what we would like them to do. Go forward. And here's just a photograph of that very same thing. So this is a fairly large, probably a PG 36 by 36. And you can see here, by the way, that the thickness of that cover, these covers can get very, very heavy once they get to that size. And all of those things certainly play a factor in terms of how you handle this product. I don't remember if I have the next slide shows that. I can't remember, Matt, I'm sorry. Yes, it does. Okay, so this is a good example of some of this product stacked up, and I think it's a good opportunity to make you aware, or at least remind you that this product line, this Quazite enclosure product line, it oftentimes is large, takes a lot of space. These things are generally heavy, and so when we're distributing these things out to customers and distributors, it's important that they take that into account. Oftentimes, distributors that we're dealing with are used to dealing with products that are smaller, lighter, easier to handle, easier to ship. So in the world of enclosures, that's unfortunately not true. So they're having to deal with this sort of thing with big, heavy boxes. They're having to be stacked up just to save space. And there's limits on how high you can stack these things. Of course, we can provide all of that backup information as to what's the safest way to handle this material. But it's important, I think, to emphasize or just remind all of you of that case. That is what I have. So I welcome questions on any of this. I'm sorry if I erased or I may have skipped over something you wanted to talk more about. I'm happy to talk about that by way of questions now.
Okay, questions, please, in the chat.
I don't see any questions in the chat, Mayor.
Okay. Well, I want to thank you for a great presentation, Rob. Thank you very much. No questions at all? Okay. We will be following up with everyone via email with Rob's contact information. Today's recording will be posted on EAP TV at www.eap.org/TV early next week. I would like to thank everyone for joining us today, and have a great day.